The National Electrical Code, or NEC, Section 210.11c3 states that bathrooms shall have at least one receptacle outlet installed within 3 feet of the outside edge of the wash basin. Further, NEC Section 210.52c dictates that bathrooms shall have a minimum of one 20-amp branch circuit dedicated to receptacles. Also, NEC Section 404.2e says that receptacle outlets in bathrooms shall be supplied by a 20-amp branch circuit. However, there are exceptions to these rules. Firstly, 210.11c3 Exception 1 states that where a bathroom does not contain a wash basin, a receptacle is not required. Secondly, 210.52c Exception 1 says that bathrooms in hotels and motels are not required to have a dedicated 20-amp branch circuit. In simpler terms, the NEC requires bathroom receptacles to be installed on a dedicated 20-amp circuit. However, it does not prohibit the lighting and fan from being on the same circuit as the receptacles. Therefore, it is permitted to have a single 15-amp circuit supplying the lighting, fan, and receptacles in a bathroom, provided that 1. The circuit is rated for 20 amps, 2. The bathroom contains a wash basin, 3. The receptacles are installed within 3 feet of the outside edge of the wash basin, and 4. The circuit is protected by a ground fault circuit interrupter, or GFCI. While it is permitted by the NEC to have all bathroom loads on a single 15-amp circuit, it is recommended to provide a dedicated 20-amp circuit for the receptacles. This will provide additional capacity for future loads and reduce the risk of overloading the circuit. Let's delve deeper into the requirements and recommendations for bathroom electrical circuits. The National Electrical Code, often abbreviated as NEC, sets the standard for safe electrical installations. It's crucial to understand these guidelines to ensure safety and compliance when dealing with electrical work in bathrooms. We'll start with the specific sections of the NEC that address bathroom receptacle outlets. Section 210.11c3 is a primary reference. This section mandates that bathrooms have at least one receptacle outlet. The placement of this outlet is also critical. It must be installed within 3 feet of the outside edge of the wash basin. This requirement is intended to provide convenient access to electrical power for commonly used appliances like air dryers, electric shavers, and curling irons, all while maintaining a safe distance from water sources. Next, let's examine Section 210.52c. This part of the NEC takes the requirements a step further by stating that bathrooms must have a minimum of one 20-amp branch circuit that is dedicated solely to receptacles. This dedicated circuit is meant to handle the combined load of multiple appliances that might be used simultaneously in a bathroom. By having a dedicated 20-amp circuit, you reduce the risk of overloading the circuit and causing a potential fire hazard. Section 404.2e reinforces the need for a 20-amp branch circuit, specifying that receptacle outlets in bathrooms must be supplied by such a circuit. This reiteration underscores the importance of a dedicated circuit for bathroom receptacles. Now, it's important to be aware of exceptions to these rules. Exceptions exist to address specific situations where strict adherence to the standard requirements might not be necessary or practical. Exception 1 to Section 210.11c3 states that if a bathroom does not contain a wash basin, then a receptacle is not required. This exception recognizes that in the absence of a sink, the need for a receptacle outlet is significantly reduced. For example, a small powder room with only a toilet might not require a receptacle. Another exception is found in Section 210.52c. Exception 1 to this section provides that bathrooms in hotels and motels are not required to have a dedicated 20-amp branch circuit. This exception acknowledges that the electrical usage patterns in hotel and motel bathrooms can be different from those in residential bathrooms. Hotel and motel bathrooms often have lower and less predictable electrical demands, making the dedicated circuit less critical. To summarize the key interpretations of these code sections, the NEC mandates that bathroom receptacles be installed on a dedicated 20-amp circuit. However, the code does not explicitly prohibit the lighting and fan from being on the same circuit as the receptacles. This leads to a permissible scenario where a single 15-amp circuit could supply the lighting, fan, and receptacles in a bathroom, but only under specific conditions. The first condition is that the circuit must be rated for 20 amps. Even though a 15 amp circuit breaker might be used, the wiring and other components of the circuit must be capable of handling a 20 amp load. Secondly, the bathroom must contain a wash basin. This condition aligns with the general requirement for receptacles in bathrooms with sinks. Thirdly, the receptacles must be installed within 3 feet of the outside edge of the wash basin, as previously mentioned. The fourth and final condition is that the circuit must be protected by a ground fault circuit interrupter, or GFCI. GFCI protection is crucial in bathrooms due to the presence of water. A GFCI monitors the current flowing in a circuit and quickly cuts off the power if it detects a ground fault, which can prevent electric shock. While the NEC technically permits having all bathroom loads on a single 15 amp circuit under the conditions we just described, it is strongly recommended to provide a dedicated 20 amp circuit specifically for the receptacles. This recommendation is based on several practical considerations. A dedicated 20 amp circuit provides additional capacity for future loads. As homeowners acquire more electrical appliances, the demand on bathroom circuits tends to increase. A dedicated 20 amp circuit offers a buffer to accommodate these increased demands without overloading the circuit. Additionally, a dedicated circuit reduces the risk of overloading the circuit. Overloading can cause the circuit breaker to trip frequently, which can be inconvenient and potentially damage appliances. By separating the receptacle load from the lighting and fan load, you minimize the chances of overloading. From a safety perspective, a dedicated 20 amp circuit provides a higher level of protection against electrical hazards. It ensures that the receptacles are adequately powered and protected, reducing the risk of electrical shock and fire. Furthermore, adhering to the recommendation of a dedicated 20 amp circuit for bathroom receptacles is a forward-thinking approach that anticipates future needs and enhances the overall safety and functionality of the bathroom electrical system. Now let's talk about ground fault circuit interrupters, or GFCIs, in a bit more detail. GFCIs are a vital safety component in bathrooms and other areas where water is present. A GFCI is designed to protect people from electric shock by monitoring the current flowing in a circuit. If it detects a difference in current between the outgoing and incoming wires, it quickly shuts off the power to the circuit. This difference in current indicates a ground fault, which means that electricity is leaking out of the circuit, potentially through a person. GFCIs are incredibly sensitive and can react very quickly, typically within a fraction of a second. This rapid response time is crucial in preventing serious injury or even death from electric shock. The NEC requires GFCI protection in all bathroom receptacles. This requirement is based on the understanding that bathrooms are inherently wet environments, increasing the risk of electrical hazards. In addition to receptacles, the NEC may also require GFCI protection for other electrical equipment in bathrooms, such as lighting fixtures and exhaust fans, depending on the location and design. When installing or replacing bathroom receptacles, it's essential to use GFCI protected outlets. These outlets have a built-in GFCI mechanism that provides protection at the point of use. GFCI receptacles typically have 2 buttons labeled Test and Reset. The Test button allows you to verify that the GFCI is functioning correctly. When pressed, it should trip the GFCI and cut off the power to the outlet. The Reset button is used to restore power to the outlet after a GFCI trip. It's a good practice to test GFCI receptacles regularly, such as monthly, to ensure they are working properly. If a GFCI fails to trip when tested, or if it trips frequently for no apparent reason, it should be replaced by a qualified electrician. GFCIs are not foolproof and can wear out over time. It's also important to note that GFCIs do not protect against overloads or short circuits. They are specifically designed to detect ground faults. Therefore, it's still necessary to have proper overcurrent protection, such as circuit breakers, in the electrical panel. When working with electrical circuits, it's always best to consult with a qualified electrician. Electrical work can be dangerous if not performed correctly. A licensed electrician has the knowledge and experience to ensure that electrical installations are safe and compliant with the NEC and local codes. The electricians can also help you assess your electrical needs and recommend the best solutions for your situation. This includes determining the appropriate circuit sizes, wire gauges, and overcurrent protection devices for your bathroom electrical system. In addition to GFCIs and dedicated circuits, there are other safety considerations to keep in mind when dealing with bathroom electrical systems. Firstly, electrical outlets and switches should be installed at least 3 feet away from bathtubs and shower stalls. This distance helps to prevent water from coming into contact with electrical components. Secondly, wiring should be properly insulated and protected from physical damage. This is especially important in areas where wiring might be exposed to moisture or impact. Thirdly, electrical panels and junction boxes should be accessible and properly labeled. This allows for easy identification and maintenance of electrical circuits. Fourthly, any electrical work should be inspected by a qualified electrical inspector to ensure compliance with codes and standards. A professional electrical inspection can help identify potential hazards and ensure that the electrical system is safe and reliable. In conclusion, understanding the NEC requirements and recommendations for bathroom electrical circuits is crucial for ensuring safety and compliance. While the code allows for some flexibility in certain situations, it's generally recommended to provide a dedicated 20 amp circuit for bathroom receptacles and to use GFCI protection for all outlets. By following these guidelines and consulting with a qualified electrician, you can create a safe and functional bathroom electrical system that meets your needs and protects you from electrical hazards. Remember to always prioritize safety when working with electricity and to seek professional help when needed. The electrical work can be complex and dangerous, and it's always best to err on the side of caution. By taking the necessary precautions, you can ensure that your bathroom electrical system is safe, reliable, and compliant with all applicable codes and standards.